Lesson 8.5, using properties of trapezoids and kites. Today we will use properties of trapezoids and kites. What is the value of x and y? So if we have a 360 degrees in a quadrilateral, minus 55 equals 250. Divided by 2 is each of them is 125 degrees. For the next problem, ray AX and BY intersect at point P. What kind of triangle is XPY? It's an isosceles triangle. It is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. So the trapezoid has two pairs of base angles. Angle A and angle D in this trapezoid are one pair of base angles. And then angle B and angle C are the second pair. The non-parallel sides are called legs. And we can use this on a coordinate plane. We can show this. QRST is a trapezoid. And we know this because if we compared the slope of RS and the slope of OT, we find that they have the same slope, so they're parallel. Okay? The other two sides are not parallel. That's what makes it a trapezoid versus a parallelogram. Let's practice some of these. If in example 1, suppose the coordinates of point S are 4 and 5. What type of quadrilateral is this? So if we go back to point S, and instead of having S at 2, 4, we have S at 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Now this side is 3 lengths and this side is 3 lengths long. And this has a slope of undefined and this has a slope of undefined. So there are two sets of parallel lines. And that would make it a parallelogram. Okay. And then which of the interior angles are supplementary? If you remember our theorems about parallelograms, the consecutive interior angle theorem tells you that the interior angles that are consecutive are supplementary. So for instance, in that one we redrew, S and T, or T and O, or O and R, or R and S, those would be supplementary. Isosceles trapezoids. If the legs of a trapezoid are congruent, so not the bases, but the legs, now it is an isosceles trapezoid. Theorem 814 tells us that if a trapezoid is isosceles, then each pair of base angles is congruent. Theorem 815 tells us if a trapezoid has a pair of congruent base angles, then it is isosceles. So these are converses. If it's isosceles, then each pair of base angles is congruent. If this has a pair of congruent base angles, then it's going to be isosceles. And then 816 says if you already know it's isosceles if and only if its diagonals are congruent. So if its diagonals are congruent and it's a trapezoid, then it is an isosceles trapezoid. Recall that a midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. So the mid-segment of a trapezoid is the segment that connects the midpoints of the legs. The theorem below is the theorem for the midsegment of trapezoids, but it's similar to the midsegment theorem for triangles. So the midsegment of a trapezoid is parallel to each base, and the length is 1/2 of the sum of the lengths of the bases. So you would add AB, you would add DC, you would take 1/2 of that. So in the diagram, MN is the midsegment of the trapezoid. So you would add PQ to SR, 12 plus 28, and you would take 1/2 of that. So the length is 20 inches. Use the diagram below. If EG is equal to FH, EG is equal to FH, then it is a trapezoid. Is this an isosceles trapezoid? Yes, it is, because we have a theorem that says that if and only if so we're going to use this diagram. If EG is equal to FH, is the trapezoid EFGH isosceles? If those are congruent, then it is an isosceles trapezoid. We had a theorem that told us that a trapezoid is isosceles if and only if its diagonals are congruent. If HEF is 70 and FGH is 110, is the trapezoid isosceles? Well, this is a trapezoid, so the base angles are congruent. So this would also be 70 degrees, and this would also be 110. Since these interior angles are 180 degrees, it is isosceles. Okay, so by the consecutive interior angles theorem, these are 180 degrees. Here's the problem. Basically what it's saying to us is this plus this divided by 2, or 1/2 of it, is going to be equal to 12. So the midsegment is going to be the sum of the bases, so I'm going to call that base x, divided by 1/2. So to get rid of this 1/2, I'm going to multiply each side by 2, which is going to give me that 24 is equal to 9 plus x. Subtract 9 from both sides, and I get that this other side is equal to 15. Okay, some of you guys would have actually figured that out via number sense, saying if this side is 3 less, this side would have to be 3 more. I want you to be able to write it in a quadrilateral that has 2 pairs of consecutive congruent sides, but the opposite sides are not congruent. Okay? So the kite here, this would be the opposite side to that, but it's actually one of the adjacent sides is congruent in a kite. So if a quadrilateral is a kite, then its diagonals are perpendicular. And if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Let's apply this. Find the measure of angle D in the kite shown. Okay? So these are going to be the opposite angles that are congruent. So you're going to start, calculator here, with 360 degrees. You're going to subtract the 2 non-congruent lengths, non-congruent measurements for angles, and you get 172. Since these are congruent, they add up to 172. So 172 divided by 2 is 86. And each one is 86 degrees. Okay? Obviously, this is how you'd write up the equation. We solve, we got 86 degrees. If in a kite, the measures of the angles are 3x, 75, 90, and 120. Find the value of x. So we have 3x plus 75 plus 90 plus 120 equals 360. We don't know yet which ones are congruent. So 360 minus 120 minus 90 minus 75 is 75. So 3x equals 75. X equals 25, but it's these two that are congruent. So this is the value of x, and the two congruent angles. It's time for the daily homework quiz. Find the measure of angle A, C, and D. Well, I know that C, since they're base angles, also has to be 56 degrees. So 360 minus 56 minus 56 equals 248 divided by 2 is 124 for both A and D. So 124 for A, 56 for C, 124 for D. Next problem, find the length of the mid-segment of the trapezoid. So you're going to add up the two bases and divide by 2, and you get 25. Use the figure to find the indicated measures. X, Y, Z is 80. X, W, Z is 48. Find Y, Z, W. These are not congruent. So I'm going to start with 360. Subtract the 48, subtract the 80. And I get 232. Both this angle and this angle, when added together, have to be 232, and they have to be congruent. So I'm going to divide by 2. And this angle, YZW, is 116 degrees. And in the final problem, XO is equal to 2, and OZ, you're going to use this C diagram here. XO is 2, OZ is 2, YO is 6, OW is 8. Find the lengths of the sides of the kite. Well, I'm going to be using Pythagorean theorem here for these. So 8 squared is 64, plus 4 is 68. So the square root of 68 is 8 point, and around this to 8.2. I'm going to assume they want the tenths, but if not, I also am going to do this in simplest radical form. See if 68 is divisible by 4. It is. 68 is 4 and 17. Take out the 4, so this simplifies to 2 radical 17. I wrote 10, but that should say 17. Now, for the other side, these triangles, these parts, 6 times 6 is 36, plus 4 is 40. The square root of 40 is roughly 6.3. Or the square root of 40 is 10 times 4, which is 2 radical 10. So they wanted it in simplest radical form. So 2 radical 10, and 2 radical 17. Now you can page through in order to get the problems that you need for the homework. Wow! Don't know what he's doing.